We are Team Trojan Parse, and welcome to our senior showcase. So for this project, we are part of a larger effort using natural language processing and machine learning to study ancient languages. Our specific focus is sentiment analysis on ancient Greek and Latin texts. The objective is to train models and build tools that can detect emotional tone in historical documents and texts, so that we can analyze how emotions were expressed across genres, time periods, and social contexts. For our tech stack, we're using Next.js and Streamlit for the UI, Fast API and Streamlit for the backend, Olama for the Latin sentiment analysis, and Olama and Hugging Face for the Greek sentiment analysis.
Our new UI here. As you can see, just an easy text box, and then you have your the ability to add settings in the model, and then also a debug screen there. So with that, I'll just go ahead and show a quick demo of the new UI. So here is the new UI. So as you can see, we have this text box here and allows the user to select a model, type in some text or paste some text or either upload a text file and then submit. And then on the response, the user will see these three containers, which will have the results container, the translation container, and then the analysis container. And then also these three containers are dynamic for future teams to add or remove if need be. And then also as a user, they can send feedback, which will prompt this modal here and allow them to adjust a translation. And then the analysis will be stored here as well, some notes if they need to, and then tags. Submitting this feedback will then be stored in a database as JSON lines to then go into fine-tuning the model in the future. And also the translation here that they adjusted along with the response from the model will be stored. So yeah, so that's the main response screen here. And then we also added a menu with some features here. So Jupyter Notebooks, there's a lot of Jupyter Notebook activity in the code base, along with some of the teams using Jupyter Notebooks to develop and further build these models. So we gave the access to open up those notebooks in here from the code base and interact with them accordingly. Also exporting JSON if need be. There's another CTA there for that. Checking the status of the models. So as you can see, we have two local models connected. And then another one that's offline. But in the future for cloud services, if there's any cloud services or teams using cloud services models, they can connect them and they'll display it here as well. What else? We have the model shop here. So this will allow teams in the future to optimize and fine tune these models. So all of that feedback that's stored and collected, a user can select a model, pick a tuning strategy here, and then some optional parameters there, and then go ahead and train that model. And that'll go into a job queue, which you can see here, that will go off to fine tune the models.
To go a little bit more in depth on the Latin sentiment progress. So we have the Olama model, and the reason why we chose that, it's an open source model that was previously trained a lot on Latin and a little bit of Greek, just so that way you have a good basis to have a faster turnaround for a working product. It receives file uploads like XML, CSVs. You just upload that in there, and the model is able to review that. It also does raw text submissions as well. So that way you can see and not have to have a file. You can just dump the text in there, and it'll be able to recognize that the language is Latin. It'll also only do Latin or Greek. It won't do like your math homework, won't code for you. So we put restrictions on there just so that way the model is more focused as to what its primary goal is. It produces outputs, so it has the POS tag output, does lintimization, showcases its positive, neutral, negative tags with confidence percentages. It'll also do the translation. And you can see on the right where it'll have the label as positive. It'll explain the confidence as 90%, 80% as positive, then 10% as neutral or negative. For the analysis, for the parts of speech, it'll call out whether it's a verb or a noun. And then also the words that make it think that way as well. So that way you have a better understanding as to how the model came to that conclusion. And then finally, for the translation, we had to add in some context for that translation, such as whether it was military or political. So that way we could get the accurate translation for that time period. And that's for the Latin sentiment process.
Now, just to talk a little bit about our Greek sentiment model progress. So our model has been uploaded to Hugging Face with an MIT open source license. So this license would allow for other developers and other researchers to use and improve upon our model. You can see that in the top right-hand corner. You can find our model at Hugging Face rtun/GreekBert for text classification. And then, next steps here is to kind of add some more documentation to make it easier to use and to add some test results to really show whether our model is functional or not, or whether it's an improvement upon the original model that was trained off of. And so our model in our CSV file outputs was called GreekBERT v2, and we compared to the original model that it was trained upon, which is called EmotionBERT. And so we have a diff.csv output to compare the labels and confidences between the two models. And so you can see that down below where we have a Greek sequence and then the translation. So the first one is a man of Abdera. And EmotionBERT recognizes this as trustworthy with a 42% confidence percentage. And our new GreekBERT model recognizes this as joy with a 99% confidence. So a big increase in confidence, and that's kind of seen across the board with our new model, where output confidences have increased by 21% on average, but the confidence ratios are concerningly high, averaging around 98%. So there's potential that these are untrustworthy labels and that we maybe need to make some optimizations to improve our model even further. But we're definitely seeing some progress. And yeah, so next steps here is to kind of validate these labels and compare them to the original model with Dr. Bozier to figure out, where we can improve our new model.
So to wrap up the semester, in the user interface, we're going to conduct testing once all the models have been integrated into it. And then we are going to continue our general unit testing of all the features. For the Latin sentiment, we are going to fine-tune the model. Now that we have access to HyperGator, I will be validating outputs with our advisor, Dr. Boisio. And then we are going to integrate the model with the UI better. And then for the Greek sentiment, similarly, we are also going to be integrating it with the UI and validating the output with Dr. Boisia. And then we are also going to be creating Hugging Face documentation for future use cases. And that's the end of our presentation. Thank you.